Hi, welcome back. Today we are going to see an case study on sensor and transducer in HVAC applications. So, may I know what is the difference between the sensor and transducer in HVAC application and how it can be used in the HVAC applications? So, first of all, we should know the difference between the sensor and transducer. And a sensor is a device which is used to measure the physical property, like I want to measure an temperature, I want to measure an pressure, I want to measure an light energy, I want to measure an motion, something. So I need to measure some physical quantity, some physical property that with the help of an sensor. So and sensor which is used to convert the physical property into an electrical signal, and physical properties can be converted into electrical signal in order for the measurement purpose. It is used for the various purposes. Okay, so it can be most important in automation control and data collection, etc. And the transducer. And transducer is also a device which is used to convert one form of energy into another form of energy. So here and sensor which is sensing a physical property, physical quantity, and it can be converted into some other form. But in transducer, it is generally which is used to convert the energy from one form into another form. Okay, that is nothing but an transducer. So what is the difference between the sensor and transducer? So in simple, we will call like measure node. Here all the sensors are transducer. Just you can think, all the sensors are transducer, but all transducers are not a sensor. But all transducers are not a sensor. That means, just we can see the sensor. First we are sensing the physical quantity. The sensitive quantity is converted into some other form. That is a sensor. But in transducer, it doesn't have any sensing property. It doesn't sense any physical property. Just it convert the one form into another form, like mechanical energy into the electrical energy, or kinetic energy into the electrical energy. That is which is used to convert one form into another form simply. That is the main difference. And you can see here the first one, which is a transducer, which is used to convert the one form into another form. But a sensor, it senses the physical quantity. Then only it will be converted into measured quantity. And the second one, it converts the electricity into electromagnetic wave. But here it senses the physical quantity and convert it into analog quantity. Okay. And third one, the transducer examples like antenna, we are using the microphone in mobile phones, loudspeakers. These are the examples for the transducers. Just it convert the one form into another form. But a sensor like an light emitting diode, torch sensor in automobile, pressure switches, etc. So the sensors which are used in the HVAC, just we are seeing the difference between the sensor and transducer. So here all the transducers are not in sensor, but all the sensors are transducer. Okay. So here and temperature sensor is used in the HVAC application. The HVAC is nothing but heating, ventilation, air conditioning. Okay. So why we have to use this temperature sensor? It is not only to control the room temperature. It is not only to control the room temperature, but also to measure, to monitor and control the temperature in the rooms and installed pipe and duct. Okay, which is either cold water or it may be hot water in a buildings. So the temperature sensor like a thermometer, a thermostat, smart valve, indoor valve, thermistor, so like that we can use a number of temperature sensor in the HVAC applications. Okay, so it can be used for the different applications like heating furnace or heat pump, chiller, cooling tower, air conditioning system, etc. And so what is the operation of this temperature sensor in the heating, ventilation, air conditioning applications? So the first one, it's sensing the temperature sensor. Okay la. So it often, and here we can use a thermistor and RTD, that is resistance temperature detector. So the temperature sensor which is placed where we have to measure the temperature. So the sensor are designed to change the electrical property like resistance. It is according to the temperature variation. So first of all we have to insert, we have to keep an temperature sensor where we have to measure the temperature. So the sensor, it senses the variation in the temperature. It senses the variation in the temperature. If the temperature is varies, the physical property, resistance of the temperature sensor will vary. First one. And second one, we have to detect if the resistance is gets changed, it is directly proportional to the temperature changes in the building or in a particular environment. So we have to detect whether the resistance is changes or not. If the resistance are changes, it is directly proportional to the temperature changes in the environment. So we have to detect the change in temperature. And third one, signal conversion. So we are detected the temperature changes, so that information has to be converted. That information has to be converted into the corresponding electrical signal using a suitable circuit. So that is nothing but a signal conversion. We have to convert from that temperature changes, resistance into electrical signal. So that is nothing but third one. And fourth one, transmission. The converted electrical signal has to be transmitted from the signal conversion into the control unit. That is nothing but signal transmission. And fourth one is control. So here we have to take the appropriate control, whether we have to heating or we have to cooling or we have to provide the ventilation. So based on the temperature changes, if the temperature is increased, we have to apply the cooling. If the temperature is decreased, we have to apply the heating. So we have to take the necessary control action. That is nothing but in fifth one. And sixth one, feedback loop. So we have to continuously monitor the temperature changes in the environment in order to take the appropriate action. That is nothing but in feedback loop. So these are the few types of temperature sensor which are used in the heating, ventilation, air conditioning applications. That is nothing but RTD, resistance temperature detector. And this is a thermocouple. So here just you can see an RTD, if the temperature changes and resistance of the metal is gets changed. So with respect to resistance, we can able to measure the value. Okay, and here in the thermocouple, there are two elements will be there. The two element is made up of two different material. So if the temperature is changed, the material of the resistivity gets changed. So we have to measure the voltage across the two different points. That is nothing but a thermocouple. And thermistor can be used, and thermistor is a small device and RTD is a big device. Okay, so a thermistor can be used to measure the temperature. If the temperature gets changed, the resistance of the thermistor gets also changed. So with the help of change in the resistance, we can able to measure the temperature in the environment. Okay, now okay, and so these are the few reference for this case study on how the sensors, that is sensor and transducer in HVAC applications. Thank you.